Hello, welcome to section 3.6, which deals with solving applications with linear inequalities. Okay, so the only point of this section is to solve, you like how the book says applications, but technically it just means word problems. It's a fancier way of saying word problems. I wonder if it's still intimidating or not, but anyway, that's what that is. Okay, so we're going to do that. So let's go through the steps really quick. First, we need to read the problem, obviously. And when you're reading the problem, make sure that you focus in on what is this problem asking me for? What is it that they want to know? What question am I trying to answer? That, in mathematics, it's the understanding of the problem is the first step. I would say maybe even 60% of the work is understanding what's being asked of you or what your goal is. Okay, so that's the second step, identify that. Then once you identify what they're asking for, be it speed or time or distance or money or quantity or whatever, you use a variable to represent that. And then you can translate that into an inequality, depending on the language involved in the problem. So, like at most or greater than, less than, at least, that kind of stuff. And then you solve it, and then it should make sense, okay? All right, so let's go ahead and get into it. Okay, Emma got a new job, and she will have to move. Her monthly income will be $5,265. To qualify to rent an apartment, her monthly income must be at least 3 times as much as the rent. What is the highest rent Emma will qualify for? Okay, so first we need to find out what is the question. What are they asking? They're asking the highest rent Emma will qualify for. So we're going to let R be the rent, okay? I mean, you could use X, I guess, whatever. But so what is it that they what is the sentence or the keywords that describe the rent? Okay, so her monthly income must be at least 3 times as much as the rent. So basically the income has to be at least 3 times the rent, okay? At least. So that's the keyword at least, okay? So the monthly income is kind of like the the maximum, right? It can't be any more. When we have a fixed income, so her monthly income is $5,265, yeah? So the rent, okay, or at least 3 times the rent has to be at least that much, okay? So it has to be less than or equal to $5,265, okay? So now we just solve for R. So divide by 3, and we get, so let's go ahead and do that. Here, 5,265 divided by 3 is 1,755. So the rent, she can afford at most 1,755, okay? So that's the maximum rent. Maximum rent is 1,755. Okay, so that's good. Let's do the next one. Alan is loading a pallet with boxes that weigh 45 pounds. The pallet can safely support no more than 900 pounds, right? So it has to be, the maximum is 900, okay? And each box weighs 45. So how many boxes can he safely load onto the pallet? So X is going to be number of boxes, right? That's what they're asking us, okay? So, and each box is 45 pounds. So 45X is going to be the total weight. And the weight has to be no more than 900. So that means that the 900 is the maximum. So then you divide both sides by 45. We get X is less than or equal to 20. So he can do a maximum of 20 boxes. So maximum 20 boxes. He cannot do any more because then it'll be over the weight required. Okay, let's do another one. Dawn won a mini grant of $4,000 to buy tablet computers for her classroom. the tablets she would like to buy cost $254.12 each, including tax and delivery. What's the maximum number of tablets that Dawn can buy? Okay, so the maximum, so again, right? So maximum, what's the amount that she has is 4,000. So whatever she spends on tablets has to be less than or equal to that, okay? I mean, it makes sense, right? Because if it goes up, then she doesn't have any more grant money for that. She cannot afford it. So the tablets cost $254.12. Oh, sorry, this is a 5. Wait, let me erase it. $254.12. But then the number of tablets, let's let X equal number of tablets. Okay, so 254 and 12 cents times X represents the amount of money that she spends for the tablets, and then the maximum value of that is 4,000. So this is our setup, and then we just solve for X. So we divide both sides by 254 and 12 hundredths. So then you get 4,000 divided by 254. Oh gosh, 4,000 divided by 254 and 12 cents. And you get, I'm sorry, 1, 2, 254, 1, 2. And that's 1574. And so the number of boxes has to be less than or equal to 15.74. I mean, tablets. Why did I say boxes? Tablets, right? But you can't have 74 1/100ths of a tablet, right? So if we get 16 tablets, that's too much money. So it has to be less than or to 15 tablets. The maximum is 15. Because 16 would be too many. 16 times 2, you know, even if you were just to get to try it out, you know, let's say we go, oh, you know what, maybe she could do 16 tablets. If you even just multiply them together, you would see that this is equal to 4,065 and 92. So wait, that's too much money. Okay, so the max that she can get is 15. She can buy a maximum of 15 tablets. So sorry, I forgot to box my answer. Oh my goodness. Okay, let's see here. Tiffany just graduated from college, and her new job will pay her $20,000 per year plus 2% of all sales. She wants to earn at least $100,000 per year. So she's ambitious. So for what total sales will she be able to achieve her goal? Okay, so basically, how much is she going to earn? So let's say for what total sales. So let's first of all let X equal total sales, right? Okay, and then it says here that her job, what is her income? It will be 20,000 plus 2% of total sales, okay? And she wants to earn at least, so that it has to be greater than or equal to 100,000. Okay? So now let's go ahead and solve for X. So 0.02x is greater than or equal to 80,000. Then divide that by 2 hundredths. Sorry, so 80,000 divided by 2 hundredths. $1,000 per year plus 2% of all sales. 100,000. Okay, just making sure. So. So she has to sell for over $4 million. Is that right? That sounds kind of crazy, but it must be right though. Maybe she has a job where she sells like crazy life insurance or something. to huge companies. That would make sense. Okay, so Sergio and Lizeth have a tight vacation budget. They plan to rent a car from a company that charges $75 per week plus 25 cents a mile. How many miles? So that's they're asking how many miles and still keep within their 200 budget. So this means that it's a maximum problem, right? So because when you want to stay within a budget, whatever you spend has to be less than or equal to whatever it is that you're budgeting. So we're going to let M be number of miles. Okay. And then it's $75 a week plus 25 cents a mile. So let's say here, so it would be 75 plus, and then 0.25 times X, or M, sorry, we chose M. So let's go ahead and solve for M. Okay, so we get 25 hundredths M is going to be less than or equal to 125. So then 125 divided by 0.25. M has to be less than or equal to 500. So they can only, the maximum that they can travel is 500 miles. Okay, cool. Very good. All right, so now here we have Elliot has a landscape maintenance business. His monthly expenses are $1,100. If he charges $60 per job, how many jobs must he do to earn a profit of at least $4,000 a month? Okay, so he spends this much, but he makes $60 per job. And the question asks for how many jobs. So X is equal to number of jobs, right? Per month, right? Because we're talking about 1 month. Okay. So 60X represents this is the money he comes in, right? The revenue, right? Money coming in. But he has a expense of 1,100. So we have to subtract that from whatever money he gets in because they're asking about profit. So remember, revenue minus cost is equal to profit. Okay, so if he wants to do it at least 4,000, this has to be greater than or equal to 4,000. Okay. All right. So then we're solving for X, 1,100 to both sides. And we get 60X greater than or equal to 5,100. Divide by 60, both sides. Okay. And then what does that become? 85. So he has to work at least 85 jobs. So at least, so Elliot must work at least 85 jobs. Okay, and that's it for the section 3.6. Again, this is 309 to 331 odd. They're not that many. Good luck, and I will see you on the next video.